So the topic of this lesson is identifying types of linear systems, and Landon sent me a question that fits right in with that, so we're going to go ahead and use it. He said he needs to know what type of systems these are, and he has three systems of equations here. Now we need to remember that there are three general types. There are consistent systems where you get one solution, one point on our graph that both lines meet at that solves both equations at the same time. One xy coordinate that is true for both equations. Or you have inconsistent. An inconsistent system has no solutions. That's where you have two lines that are parallel. They go side by side and they never actually cross, so there are no solutions. There's no place where they meet. This one here looked more like this. We had two lines that crossed at one point, and that one point was your solution. And the third possibility is that they are dependent. And dependent means that there's an infinite number of solutions. And that's where you have one line right on top of the other. Where anything that works for one equation will also work for the other because they're effectively the same equation. So let's take a look at the three possibilities he has here. We have 2x minus 5y equals 3 and negative 4x plus 10y equals 3. So let's see if we can solve this one really quickly. 2x minus 5, let's do elimination. Let's take this first equation and multiply everything by 2 so that we can use elimination to solve this system. So that first one then becomes 4x minus 10y equals 6. And we have negative 4x plus 10y equals 3. So now we add straight down. 4x minus 4x is 0. And negative 10y plus 10y is 0. And 6 plus 3 is 9. So these two equations then come out, when we solve them together using elimination, we come out with 0 equals 9. That's obviously not true, which is the hallmark of an inconsistent system. If you solve the two equations and what you come out with is a statement that is not true, then there are no solutions that work for both equations at the same time. So this system right here is inconsistent. There are no solutions. Now let's take a look at the next one. 5x minus 3y equals 11 and 7x plus 6y equals 12. This one we do the same thing to start with. Let's multiply this whole side by 2 and we'll get 10x minus 6y, 10x minus 6y equals negative 22. And we have 7x plus 6y equals negative 12. We add straight down and we get 17x, and our y's go away, and we get negative 34. So we divide everything by 2. X equals negative 2. And we have a value for x we could plug back in for y. But this tells us, since we got a single value for x, this tells us that this is a consistent system. We have one solution. We may not know what it is yet because we didn't plug it back in, but that wasn't the point. The point was to find out what kind of system this was. This one is consistent. So for the second solution there, we came up with a value for x, which would have given us a value for y, so that's a consistent system. And then for our last one here, we have 4x plus 2y equals 8, and negative 8x minus 4y equals negative 16. Now for this one, if we were to just take this first equation and multiply everything by negative 2, negative 4x would become negative 8x, 2y would become negative 4y, and 8 would become negative 16. So these two equations are equivalent. They're the same thing. So this one here is a dependent system. And if you were to solve this, if you were to go through and figure out what x and y is, you'd come up with something like 3 equals 3 or something similar, which would be a true statement. Unlike the inconsistent one, we came up with a false statement. This would be a true statement. So this would be a dependent system.